Let's close out the chapter with some key messages as a summary. The one I would want to highlight is, for example, the response and readiness that we talked about before as a part of the adaptation. So a new report that came out, I think, in 2019 on global adaptation from the commission that includes Bill Gates and the ex-UN General, Secretary General, the Korean guy whose name skips my mind right now. They highlighted the need for early warning systems as well. So India invested millions of dollars in weather and climate predictions. So it also has a network of observations, and it has set up a agromet decision support system which works very well as a adaptation. So this is the example of adaptation in terms of response and readiness, making the food production system and water resource system weather ready and climate resilient. You can think of it that way. So observed weather data is ingested into IMD models. The agromet decision support system uses a global forecast model that does short term, so day 1 to 3, medium range, day 3 to 10, and extended range, weeks 2 to 4, and seasonal predictions which go from 3 months to 12 months. And it also has now participation in the AR6 projections of 21st century and longer with an Earth system model. So GFS is basically the global forecast system, which is now GFES, Global Ensemble Forecast System, inherited from NOAA's model from the US, but India has worked on improving lots of things, making it region specific, focusing on monsoon processes and improving monsoon predictions and so on. So there are short SMS based on 5-day forecast information issued, 10-day agromet bulletin issued. So agricultural information is in terms of district-wise major crop and cultivar information, dynamic crop weather calendar, crop health and soil wetness, crowdsourcing through networks. So considering all aspects of monsoons are changing already and extreme events are clearly on the rise, including widespread floods, this is a adaptation already. Okay, so overall for the chapter, the key message is that we need to have these region specific reliable projections at various time scales, from the so-called societally relevant time scales of these response time scales of weeks to months, and years to decades, and then longer time horizons, keeping in mind again that the evidence is now really very convincing and attributable to anthropogenic climate change. This one is talking about a living planet index calculated by tracking the abundance of more than 14,000 populations of almost 4,000 vertebrate species. So index value set to 1 at 1970, and you can see the massive drop. That's not good news, okay? Just the temperature metrics for dangerous climate change or dangerous anthropogenic interference is obviously problematic. If you want to do adaptation and mitigation, we need to consider non-climate impacts, non-temperature impacts, socio-economic impacts, biophysical and biogeochemical impacts, and their feedbacks to the climate system. So threats obviously abound. Radiative forcing based on CO2 equivalent calculations are not appropriate for mitigation efforts of greenhouse gases. We need to worry about the carbon cycle feedbacks in addition to radiative forcing calculations. So all the non-direct impacts, indirect impacts as well. Adaptation strategies require robust assessments of future climate change and its biophysical and socio-economic impacts at global and regional scales. regional scales is where adaptation is going to be the most critical to reduce vulnerability, increase resilience, reduce risk, and so on. Rate of climate change matters and it depends on feedbacks, and the Earth system view of doing this is essentially to account for all those feedbacks, including socioeconomic feedbacks. Okay, so looking at the Living Planet report again, tracking vertebrate populations, it looks at climate change threats for terrestrial, freshwater, and marine species. Um, Overexploitation, so that's a non-climate impact on these species, so like fisheries and other activities. Pesticides killing various things are not included this, but environmental exploitation in general. Habitat loss and degradation, invasive species and diseases, and pollution. So you can see that climate change as measured by physical parameters may not always be the biggest impact depending on what you are looking at. It could be overexploitation, which is still human activity, habitat loss and degradation, which is human activity, plus maybe sea level rise, extreme events, loss of glaciers, snow melt, and so on and so forth, and increased nutrient runoff into coastal waters, etc., which includes pollution, excessive fertilizer use, etc. Unintended consequences include introduction of invasive species and diseases, even by simple activities like cargo ships carrying or any ship carrying ballast water from one place and dumping it elsewhere. Lots of examples exist of introduction of invasive species through those activities which are now being better regulated and controlled. Okay, so that's the chapter. It's rather long with lots of information about what are the key issues, and as I said, it does raise lots of issues, uncertainties and feedbacks, unknown processes, epistemic uncertainties, and stochastic uncertainties, and so on. But to the extent that climate change is inexorable and we are not going to change our behavior anytime soon in terms of reducing emissions, as we said before, despite the 25-year negotiations, the emissions show no trend of reduction. The 7% or so reduction because of COVID lockdowns, etc., is already heading back up. So we are essentially on a business as usual trajectory right now. So as we saw, mitigation and adaptation should have already started in terms of at least removing short-lived climate pollutants like black carbon, methane, and ozone, and so on. Okay, so we will see other details in the remaining two chapters, but the idea is not to be discouraged by the complexities and uncertainties and so on, but to learn that decisions have to be made under uncertainty and the best information available at the time has to be used, with the idea that the adaptation plans are flexible enough to account for new information, improved knowledge, and improved projections coming along as we go forward. Not always possible to make everything so flexible, like hard structures built cannot easily be changed, but many of the options can be left quite flexible. That should be an option from the beginning anyways.